solution. Now, this is a good general solution question. I think this is part 2 actually. You had to show this was the case and then solve it. Okay. And again, it looks awful for much of similar reasons. It's got that powerful. So let's go ahead and do it. Right. First step. First step. Okay, so you can, let's do both of those steps. I'm going to introduce a substitution just to get my powers down. You don't have to, but it does make it easier. Okay, and then let's factorize. Okay, so here's a good substitution to make. Let u equal cos squared theta. So you've got 4u squared plus 3u minus 1. Can anyone tell me what the factorization is?
4u minus 1 u plus 1.
Not bad. Good. Okay, so there you go. So now I've got my two solutions for cos squared theta. Okay, one's going to be a quarter, and the other one's going to be minus 1. Okay, so you can see that that one doesn't give you real solutions. Okay, so you can ignore that. But when you get to a quarter, okay, cos squared theta equals a quarter. So cos theta is plus or minus a half. Okay. Now, this is two separate ones, right? With two separate related angles. Okay. Theta can be either, if we're just talking about single angles, okay. You can take 60 degrees, that'll give you your first quadrant solution, right? Or, what's the second quadrant solution? It's 180 minus this, right? That's what all second quadrant answers are. So it's 120. Okay? So if you want to go from specific solutions, these are the two related angles, base angles, okay, up to your general solution. What is general solution for cos? I'm in degrees, by the way.
2 180.
It's the 2 times 180. So it's going to be 360. This is my 2 pi.
360
And, right, plus or minus. There's 1. And I've got another 1. Okay? Of course, I've, no. And you can generate some solutions. We'll do it in a second, actually. Don't forget, you've introduced the counter, so don't just leave it hanging there in the middle there. Introduce it. Okay. All right. Yes. Yep.
Does it have to be positive integer or just integer?
No, any integer will work. Okay. So now, what do I do with this? Okay. Now, to be fair, I think that's fine. I think that's fine. Okay. But you can go one better, and if the question underneath says, no, go further than this, the answer is actually simpler, which it is, okay, the question is, well, how do I get from this to something simpler, okay? So here's what I'm going to suggest, and this will often help you in any kind of situation where you've got two different general solutions, and you're trying to see if they coalesce into some other sort of more unified way, okay? So draw yourself out a number line, okay? I'd recommend it at least goes from like 0 to 720 or something like that. So,
solution is more general than this general solution.
So why can't theta equal 240 or
you mean like here? Because when you're going from here to here, and all I'm doing is, I'm getting, because actually, sorry, this really said find the general solution. Okay, so if I want the general solution, what am I going to stick in here? Okay, all I want is the one most basic angle that will make this equation work. Okay, if on the other hand I was giving like specific solutions from 0 to 360, okay, I would say 60 and 120 and 240 and 300. Okay, because it would hit all 4 quadrants because it's plus or minus. Okay. But since what I'm really doing is leading on to general solution, okay, I only want this one and this one. If I were to say, 360 plus or minus 240, okay, this answer would actually overlap with this answer. But it would just be an awkward way to say it. Like, why would you use such a huge angle? Like, I mean, if you want to use a huge angle, why not go with like 360 plus or minus like 600? Because that'd work too. Or 960 or whatever. So just by convention, we just want the smallest one that makes it work. Okay?
So how do you know where to stop?
Well, have a look at whatever value you've got here, and then your related angle will be either from, it'll be 0 to 180 basically.
Oh,
Because if
will
it's
it have to be
positive, yeah, if it's positive it'll be in the first quadrant, and if it's negative, think of this, right? Positive will land in the first quadrant. If cos is negative, like cos theta is minus a half, it'll land in the second one. And you never need to go further, because I've already got all the bases covered.
What if it was like sine?
If we sine, because when you go from here to here, you don't get anything more useful, okay? Instead of saying a bigger angle, you just say plus or minus, right? So your related angle would be between minus 90 and 90. Okay? So I can give you another example in a second, but I'll try and finish this question first. Alright, where was I up to? I got a bit sidetracked. I'm going to draw a number line, okay, and I'm going to put these solutions on my number line and see if I can notice any patterns, okay? So first let's put some numbers down. So 120, 180, 240, 360, what am I up to? 420, 480. I'm almost there. Oh, that was a really convenient length. Okay, so now, when we have a look at our solutions, okay, let's just do the first one first. 360 and plus or minus 60. Okay, so what are my first solutions going to be? I'll go 0 plus or minus 60, right? So there's a solution, there would be a solution here. I did one, okay. Next lot over, 360 plus or minus 60. Is that okay? And then on my scale, I'll get one more over, 360 plus or minus 60, okay? So there's one set of solutions that corresponds to this, okay? Now I'm going to do the next one, 120, okay? Yes?
Line, not a table of values.
Don't see why not.
Okay. So, but we have to do a visual representation of.
I'm trying to sense patterns. Patterns are easier when you've got a line, as you'll see in a second, okay? Whereas the values are harder. If you're verifying values though, that's kind of not going to cut it, right? Look at my pretty line with crosses on it. Well, what does that mean, okay? But, as you'll see, when I do this one, you'll see the pattern, okay? So plus or minus 120, plus or minus, so there's one. Next one over, 360, plus or minus. Okay, and my last one over, plus or minus. Okay, now can you see kind of a better pattern to work with? The answers are much more frequent than every 360, right? Which is what the original general solution suggested. These are like, look, every 360 you should see a pair of answers, okay? But it's coming up more frequently than that, right? Because if I say take this spot here, okay, I can see solutions on each side. And the next one over, I can see solutions on each side, same distance, right? And I don't have to go 360 degrees to find the next one. I go from 180 to 360 to 540, okay? So I'm only hopping 180 degrees every time. And then going plus or minus, well, what's the distance? 60, right? So therefore, when you put together these two, okay, what you're really going to get, and this is what the answers tell you with no explanation, they say, well, that's equal to 180 plus or minus 60. Okay? Now remember I told you right at the beginning, right? I think this is fine, because this gives you all the solutions, and that's the only criteria that general solution has. Okay? And if the question just said, give me the general solution, you'd get full marks for that. Okay? However, I mean, if I'm hard pressed to think of one off the top of my head. I don't think I've ever seen this. If they said, show that the general solution was equal to this, you wouldn't be able to just write down this and then go, ta-da, I'm awesome, okay? You'd have to put down like something like this, or you'd have to get some values down so you can you demonstrate the pattern that connects this line to that one. Okay? Yeah.
So in general, for general solutions, you sort of just stop like when you get an answer, like unless they specify.
Yeah.
So in that sense, when they're like half mark allocated, it's not worth your time anyway.
No. Because this is hard. Like,
takes time.
this took me a little while to see and think, okay, what? And I already knew what the answer was. Okay, so to demonstrate that, yeah, it's not really worth it when that answer is perfectly valid. So, yeah.
Wait, did you say we have to write the line where there are two general solutions before we write the even more general solution?
You mean like if I wanted to write this?
Yeah, because I just...
Yeah, for sure. You couldn't go from here to here because the connection is not clear at all, right? So I'm trying to assess how much you understand
So
of
you
what
can't
does this
say
mean and what does
just
it imply.
You can't say it just
Definitely
is.
not.
How do you get through that as a program?
Victor?
I saw it like by, you know how it's just plus minus half?
Yep.
So it's just like, you know, just there and there. Like,
Yeah, when you write it
Yeah,
down,
yeah.
because
Yeah.
for positive half, it'll be the even multiples of 180 plus
Yes,
or minus 60.
yes.
And for minus half, it'll just be the odd multiples
Yep,
of 180.
Yep,
So then
exactly.
it's just multiples of 180.
Yeah, exactly right. So if you went about it another way, the identities would be a little more obvious.
But you know, when you get 2n pi, right? That's saying even multiples of pi.
Yep.
How do you denote odd multiples of pi? Is it n plus 1?
N plus
Or minus 1 would do it. Either is fine. Alright, any questions on that? Yep.
So, are they ever going to ask you to get to that?
Mine, but like very rare.
Is really, I can't think, this is how rare it happens, I can't think of an example off the top of my head. And for what it's worth, like, everything really is, like what we're looking for as a skill, is demonstrated in getting here. Right? It's like, oh, it's kind of cool that you see them overlap, but it's a handy thing. It's not a different qualitative answer thing.
This is the only.
Okay, everyone.